Hello Geotech Masters, welcome back to our standard penetration test tutorial series here in Geotech Masters. In our last video, we began our deep dive into the heart of the SPT, the hammer systems, and we explored the modern automatic hammers known for their consistency. Today we are going to expand our knowledge by tackling some equally important yet different hammer systems.
Have you ever wondered, how do the older, more traditional hammer systems work, like the mechanical trip or the rope and cathead methods? What are their unique operational characteristics and safety considerations? And crucially, how do these differences impact the energy transferred to the drill rods, and ultimately, our precious end values? We'll answer all these questions and more in this video, so stay tuned. As we discussed previously, the hammer drop system is the equipment that includes the 63.5 kg hammer, its lifting and dropping assembly, and a guide tube if used, which an operator or an automatic system uses to lift and drop the hammer to create the blow. In the last video, we highlighted that automatic and mechanical trip hammers are generally preferred due to their more consistent energy delivery during testing. However, it's important to understand the other types that are still commonly used around the world. Let's start with the mechanical trip donut hammer drop system. Imagine a hammer that is lifted by fingers or pawls that grip it and then release it at the exact 750 mm drop height. While it still uses a rope and cathead system for the initial lifting, the release mechanism is mechanical, meaning the operator's rope turns or the cathead speed do not significantly impact the precise drop height. These hammers are quite popular internationally, especially in regions where large truck-mounted drills might not be as common. While automatic hammers are designed for reproducibility, factors like wear and tear, or even inconsistencies in the drill's hydraulic system, can affect their performance. Therefore, maintaining consistent operation means ensuring the hammer is dropping the full, specified height and at the correct blow rate. Some advanced automatic systems, like the SPT, even continuously monitor drop heights, which greatly aids in quality control. If the ETR is known for your automatic hammer, it can even be adjusted to provide drop height slightly less than 750 mm if a reduced blow rate is desired, for example, in specific liquefaction evaluations. The key is to document any operational problems or deviations from the required drop heights, as these can influence the ETR and, consequently, your end value. From an energy perspective,